Hello, Incarnation third graders. Welcome to Math with Mrs. Martin. I hope that your family is continuing to stay healthy and safe. We miss all of you here at school. It's actually very quiet and chilly here at school today as we work on this math lesson. We are working on lesson 9 on page 805 in your book. So if you want to grab your book, go ahead. We aren't quite going to open it yet, so just follow along with me as I do a little bit of chapter review here on the board first. I'll let you know when to open your book. Earlier in the chapter you learned about perimeter. Perimeter is the area around a figure. We're going to, today, for the sake of writing, we're going to call that P when we refer to it on the board. Perimeter equals P. It could be measured in inches or feet or meter. It's the distance around a figure. Area, which we're going to label A today in class, is the square units inside of a figure. So perimeter does the outside, area is doing the inside. It is labeled with square units. So in, I think, lesson 5, if it has to do with inches, we're going to call the area square inches. If it's feet, we're going to call it square feet. And I might be writing a shortened version of square today on the board. So if you see that, that means square. Here are the equations for a perimeter and area. Perimeter, you are adding the distance around the figure. So I have an addition sentence here. First side plus second side plus third side plus fourth side will get you the perimeter. Area, you learned recently, is the length times the width. So to find the area, you're going to take the length times the width to solve for area. And that will get you the square units that are on the inside of a figure. Today we're going to be comparing different perimeters and areas. And first we're going to look at two rectangles that have the same area, So if I solve for this, rectangle's area, I'm going to write my equation. Area equals length times width. Area equals 3 times 2. Area equals 6. If I solve this rectangle's area, I would again write my equation. Area equals length times width. Area equals 6 times 1. Area equals 6. So when I look at those two rectangles, I see that the area, which is the square units on the inside, is the same. If I pretended these were gardens, I could plant the same amount of things in these two rectangles even though they look different because the inside is the same. Now let's take, for example, we want to find the perimeter of these two rectangles, and let's see what that is. So I'm going to solve each of these rectangles for perimeter. Perimeter equals blank plus blank plus blank plus blank. Because this is a rectangle, I know that this side is 2, so this side is 2, this side is 3, and this side is 3. So we're going to find our doubles and do 3 plus 3 and 2 plus 2. Perimeter equals 6, 2 plus 2 is 4, perimeter equals 10. And that is the distance around that rectangle. Now let's hop over to this rectangle and find the perimeter. Perimeter equals blank plus blank plus blank plus blank. This is a rectangle again. If this side is 1, I know this side is 1. If this is 6, that is 6. We're going to find our doubles. 6 plus 6 and 1 and 1. Perimeter equals 6 plus 6 is 12. 1 plus 1 is 2. Perimeter equals 12 plus 2 is 14. In looking at those two rectangles, I see that the perimeter is different. The perimeter on this one is 10. The perimeter on this one is 14. So we could have two rectangles that have the same area on the inside, but different perimeters. And this is what we're going to explore in today's chapter. We're also going to explore at the end some rectangles that have the same perimeter, but different areas. So it will go either way. Right now, while I erase the board, I would like you to go ahead and open your books to page 805. We are on lesson 9, area and perimeter. Two rectangles can have the same area but different perimeters, and that is the example I just showed you on the board, and we're going to explore that a little further. Listen as I read example 1 and go ahead and read out loud or to yourself with me. Elizabeth will build 2 fences, one surrounding each garden shown below. How much area does each garden cover? How much fencing will she need for each garden? So we have 2 different questions there. How much area does the garden cover? And how much fencing she will need? Fencing, we learned, is the perimeter. You put fence around the perimeter of an area. So first we're going to look at the area of each garden. Garden 1, here's a picture of it. Area equals length times width. Area equals 6 times 2. 6 times 2 is 12. So the area, equals 12, not 16. And they have feet, so we're going to go ahead and put square feet for my area. Garden 2, the length times the width. 4 times 3, length is 4, width is 3. 4 times 3 is 12. Again, we have square feet. So you can see that those 2 gardens have the same area, even though they look different. Now we're going to find the perimeter of each garden. Garden 1, which is up here. First, let's go ahead and write the sides. I know that this side is 6, and because this is 2, this is 2. I would go ahead and normally find the doubles and write my doubles together, but they already have it written in our book, so we'll just follow what they do. They did 6 plus 2 plus 6 plus 2. 6 plus 2, 6 plus 2. 8 and 8. 8 plus 8 is 16 feet. The perimeter of garden 2. I know that the other side of this garden is a 4, and the width is a 3. Again, I would normally look for doubles, but we're going to follow how they have it written here. 3 plus 4 plus 3 plus 4. 3 and 4 is 7. 3 and 4 is 7. 7 plus 7 is 14 feet. Garden 1 needs 16 feet of fence, and garden 2 needs 14 feet of fence. So you can see these 2 gardens have the same area on the inside. I could plant the same amount of plants on the inside of this garden. But the perimeters are quite different, and the look of the gardens are quite different. So 2 rectangles that have the same area, but different perimeters. Let's go ahead and flip to page 805. I really mean 806. Page 806, the second problem. Two rectangles can have the same perimeters, but different areas. So now we're going to switch gears a little bit. They're saying the same perimeter. Perimeter is the area around, but different areas, which is the area on the inside. So we're basically doing the exact opposite of what we did in the example previous. So listen as I read. Draw and label a rectangle that has the same perimeter as the rectangle shown, but a different area. First, we're going to find the perimeter and area of the rectangle. The perimeter is, we know that this side is 4, so this side would be 4, 6, and 6. The perimeter is 6 plus 4 plus 6 plus 4. 6 and 4 is 10, plus 10, or 20 inches on that rectangle. The area then becomes, remember the area is length times width. So the area is going to be 6 times 4. 6 times 4 is 24 square inches. Okay, let's continue with number 2. It says draw and label a rectangle that has a perimeter of 20 inches, but a different area. So we are looking for the same perimeter as of this rectangle, 20, but it has a different area. So I know, because it has a different area, that my sides need to be different numbers. So I'm just going to start with a different number than 6 here. I'm going to go ahead and draw my rectangle, and I'm going to say, well, this would be 7 inches. And this would be 7 inches. So that gives me 2 sides, but I know that my perimeter has to already equal 20. So let's take this 7 and 7, and that equals 14. I know half of my rectangle. But my total needs to be 20, and I need to know what these 2 sides are. So I'm going to take my total, which is 20, and I'm going to subtract it from the 2 sides I already have, which is the 14. And that will give me what these other 2 sides are. 20 minus 14, 10 minus 4 would be 6 inches. So I know that I have to somehow get a perimeter of 6 on here, but I have to divide the 6 between the 2 sides. So I'm going to take the 6 in half and put 3 here and put 3 here. And that will give me the perimeter of 20 inches. Let's go ahead and check that. Now we have perimeter equals 7 and 7 and 3 and 3. 14, 3 and 3 is 6. The perimeter equals 20. Now just for fun, let's go ahead and do the area, because we want to make sure that we have a different area. If I solved for area over here, area equals length times width. So area would equal 7 times 3. Or area would equal 21 square inches. Up here the rectangle was 24 inches. So there's my area is different, but my perimeters are the same. Let's go ahead and solve these questions. What is the length of the rectangle you drew? The length of the rectangle I drew is 3. The width of the rectangle I drew is 7. What is the area of the rectangle I drew? The area is 21. And we can go ahead and add labels. This would be a square inch, and these would be inches. Okay, let's go ahead and do the guided practice at the bottom of that page. The guided practice says, describe the length and width of a rectangle that has the same area as the one below, but a different perimeter. So here we're solving again, same area, different perimeter. On this one I know that the area equals length times width. So I'm just going to go ahead and solve for area first. Length times width would be 3 times 8. Area equals 24 yards. Now if I want a rectangle that would have the same area equals length times width, I'm going to plug this 24 into the area. 24 equals blank times blank. So I'm going to look at my multiplication chart and find two numbers when multiplied together get 24 but are different than 3 and 8. So let's go ahead and look down here. I see in my row 4, I see a 4, 6, and 4. So I could put a length of 6 and a width of 4, and I would get that area equals 24. So in describing that the rectangle, it would just look like this. A length of 6, a width of 4, and that would get you the same area. Let's move now to page, let's see, 807. And do some of the independent practice. On this page, as well as on your homework, it's very important that you read the directions because you need to know if it's asking you, is this the same area and a different perimeter? Or is this a same perimeter and different area? Because we have learned how to solve for both. So pay attention to the wording and just do what it asks. Draw and label a rectangle that has the same area but a different perimeter here. We're going to go ahead and solve numbers 2 and 4, and I'm going to let you go back and do 3 and 5 on your own. So up here it says, again, the same area but different perimeter. So of course I need to solve for area first. Area equals length times width. Area equals 5 times 6. Area equals 30 square centimeters. Now they want us to find a rectangle that has the same area, but a different perimeter, so different sides. So we're going to go ahead over here and plug in area equals blank times blank. We want the same area, so we're going to plug in that 30 equals blank times blank. I'm going to pull out my multiplication chart again and find two numbers that when multiplied together will give us that 30. I know that I see it in the 10 column. 3 and 10 also give us 30. So I could do a rectangle of length 10 and width 30 to get the same area. So let's go ahead and draw that. My length would be 10 and my width would be about 3. So it would look like this. Area equals length times width. The same area as this rectangle. You're going to go ahead and use that same strategy and solve this on your own once we're done. Let's go down to number 4. This one says draw and label a rectangle that has the same perimeter but different area than the rectangle shown. So first we have to solve for perimeter because that's what we want to be the same. So I know that this is 10 and this is 3. Perimeter equals all the sides added together. I'm going to go ahead and put my doubles together. 10 plus 10 plus 3 plus 3. 10 plus 10 is 20. 3 plus 3 is 6. My perimeter equals 26. So because I want the same perimeter, this is where we're just going to plug in a couple different numbers for the distance of the side of the length and try and find perimeter equal to 26. So let's go ahead and draw a little bit smaller of a rectangle here. And I'm going to say that this side is 7. I'm just going to say this side 7 and this side 7. So far I know my perimeter is 7 plus 7, which is 14. And to find the perimeter, to find what the other sides would be, I would go ahead and take the total perimeter that I already know I have, which is 26, and subtract it from the 14. And that will give me what these two sides are. So let's go ahead and write 7 plus 7 equals 14. And now I'm going to take this 26 minus my 14. 6 minus 4 is 2. 2 minus 1 is 1, which would give me 12. So I know that the other two sides here have to equal 12. So I'm just going to put that in half. 12 and half is 6. So each side would be 6. So if I added these four sides, 7 plus 7 plus 6 plus 6. Let's go ahead and check that. Perimeter equals 7 plus 7 plus 6 plus 6. Perimeter equals 14 plus 12. Perimeter equals 26. So here they're asking for the same perimeter. The perimeter here was 26, and the perimeter of our new rectangle is 26. That one's a little harder to do, but all you have to do is remember that when you're figuring out the next rectangle, just go ahead and make a guess on the first two sides, and then you'll be able to figure out with subtraction what the other two sides are. So you're going to work that on your own after we're done here. Let's go down to the last problem on that page and read those directions. The directions say circle the rectangles that have the same perimeter but different areas. Because we want the same perimeter, let's just go ahead and solve for perimeter. I'm going to go ahead and write an 8 here. This side is 8, so this is 8. This side's 4. This is 4. Perimeter equals, look at my doubles, 8 plus 8 and 4 plus 4. 8 plus 8 is 16. 4 plus 4 is 8. Perimeter equals 16 plus 8, which is 24. So the perimeter on this first one is 24. Let's go ahead and solve for the perimeter on this one, because we're looking for two rectangles that have the same perimeter. Perimeter equals, I know all the sides are 6 here because it's a square. 6 plus 6 plus 6 plus 6. Perimeter equals 6 plus 6 is 12. 6 plus 6 is 12. So 12 plus 12. Perimeter equals 24. Is that the same perimeter as our first rectangle? Yes, it is. So far, those two rectangles do in fact have the same perimeter. Let's go ahead and just work our last one and see if it has the same perimeter or not. This side would be 5. This side would be 9. Perimeter equals, and I'm going to look for my doubles. 9 plus 9, and 5 and 5. Perimeter equals, 9 and 9 is 18. 5 and 5 is 10. Perimeter equals 28. 28 is not 24. So you cannot circle that one. It does not have the same perimeter. So what you have left to do on this page is numbers 3 and 5. Go ahead and turn to page 808, the last page of this lesson. And because you tuned in to this nice long lesson today, I'm going to let you skip this entire page. So go ahead and work number 3 and 4 on the previous page, and then jump right into the homework, and you will be done with lesson 9. Thanks for watching.